Hello again, it's Shackleton the Explorer and Paul Beckwith, the climate scientist, climate system scientist. And this is a second part of my discussions on the question, is the Arctic warming behind a monster Saharan dust storm, the so-called Godzilla dust storm. So in June of 2020, we had the largest dust storm area-wise that we've ever seen in the satellite era. And the optical, it was thick. The dust was extremely thick and blocked more light by far than any other dust storm in June. And basically, the Arctic was at record low levels for June. And the jet stream, therefore, became very, very distorted. And there was a very powerful ridge just off Africa to the, northwest of Africa. And that created a very, very intense high. And the wind patterns circulate clockwise around a high. And that drove dust from the Sahara, which is the largest source of dust, to the atmosphere in the world. Meanwhile, the trough of the jet stream wave associated with that high, the ridge, the trough just to the east, the southeast of the high, basically created a low pressure, a thermally induced low pressure area, because the heat was so intense on the surface of the Earth, the hot air rose very quickly, created a low pressure area over the surface, so that created an intense low. The air circulating a low is counterclockwise in the northern hemisphere, so that gear meshed with the high pressure gear, and again it contributed to pulling dust off of the deserts, the Sahara Desert, and the high thermal convection brought the dust up about 5 or 6 kilometers high, and then it was carried by the so-called African easterly jet clear across the Atlantic Ocean into the Caribbean and Latin America and into North America, okay, over the space of about, a week to 10 days or something like that. Surprisingly, that dust was not sufficient to cool the oceans enough to suppress the tropical storm season, the hurricane season, and we had a record number of storms, 30 storms in the season. So, this is very, very unusual situation because of the size and the intensity of the dust storm and the fact that it didn't suppress the hurricane seasons. This guy, he wants more food, so he's starting to be a rebel. So we'll put him down. Okay, so let's talk about the paper, and I'm going to show you Earth Null School to show you exactly what happened during the event. Okay, so this was the first article I showed you, just to refresh your memory. It's the Weather Network. You can look at the title, just Google the title, and you can get this article. And then this is there's a link on that first article to the Scripps article. And on this article, there's also a link to the actual paper. So the June 2020 dust storm, it set records in terms of geographic size and aerosol optical depth. The aerosol optical depth, or AOD, is a measure of the thickness of the dust, and it's determined by the ability of satellites to see through it in the optical spectrum. So the dust reached 6,000 meters high, almost 20,000 feet. Its thickness was double what had ever been recorded during the month of June during the history of the satellite record, which dates back to 1995 for dust. And the study was just published in Geophysical Research Letters. Okay, so basically a high was here, a low was here. These things meshed, the geared, picked up all the dust, transported it up because of the convection from the surface, the hot air rising very rapidly, carrying the dust from the surface. It was grinded off by the winds, high winds, and then it was carried right across the Atlantic. Okay, basically, okay, so that's the gist of it. So let's have a look on Earth Null School. So go to Earth Null School, And what you do is, click back here to go back a day, and you can see the dates appearing here. So I set this as 0601, which is June 1st. Okay, and I'm looking at particulates, I'm looking at the wind, I'm looking at PM10. You can also look at PM2.5. This is particles that are 10 micron and smaller in size. And you can see already there's a layer here of the dust sort of crossing. So the African easterly jet is going on, but there's not a lot of dust in it at the moment. Now I'm going to cycle through. This is only cycling through about 8 hours at a time. Okay, but I'll just go quickly here, and you can look at the pattern of the dust, ebbing and flowing across. We're June 6th, June 7th. You can see it picking up a bit. There we go. It's a bit more. This is June 9th. June 9th. I'm still cycling through. Now you can see it building up quite intense here. June 11th, but you ain't seen nothing yet. There it is. It's building and building and building and building. And look at it stretching more than halfway across the Atlantic. This is June 13th. And there you go. Look at the intensity of this dust. So it's covering a vast area, and it's very, very intense. If you click on areas here, it gives you the number of micrograms of dust per cubic meter of air integrated up through the atmosphere. So even out here, it's very, very high compared to, these sort of numbers here. It's like at least 10 times higher, and here it's, way, way higher. So anyway, we'll continue through. Look at the intensity here. So 500 micrograms per cubic meter, and it's tracking across. Okay, this is the 19th of June, and here we go. It's extending all the way across. It hits the Caribbean, it hits Latin America, starts curling up through the Gulf of Mexico. This is June 25th now, going right up into the southern U.S. Okay, this is the 10 micron particles. Play around with this. You can see we'll go back a little bit to where it's more intense, and you can look at the 2.5. There's less of them. Of course, there's even less of the PM particles, 1 micron and smaller. Okay, but the dust is all there, generated from the Sahara. We'll just keep going a little bit, and you can see how it dissipates. Okay, so this is kind of always happening, this sort of level, and you can see how during the Godzilla event, it greatly accelerated. Now, I want to do the same sort of thing. This is now the mean sea level pressure. So looking at wind, looking at surface, looking at mean sea level pressure. So this is a high area. This is 1010 hexapascal. This is a low area. So the high is this is kind of a brownish color. So let's cycle through and see what happens. Okay, so you can see this is the 8th, the 9th. Okay, so let's just keep going this is the 15th, so we've got a pressure of 1014 right here. Look, this is the high pressure here. So the wind is gearing this way, picking up dust from the Sahara, and the low will be down here. Let's see if that develops even more. So, okay, here we go. So this is the 17th, so we've got a low pressure here. We've got a high pressure here. That creates the gearing, picking up the dust and sending it across. So let's have a look. So it moves up. This is the 20th. Okay, and here we go. So look at the pressure there, 1027 hexapascal. Very high pressure at sea level. Nominal is 1013. And over here we've got 1007. We've got a relatively low pressure there. High pressure there, creating the gearing. Okay, so you can clearly see what's going on, and we'll just continue it. Okay, and the reason this pattern is fairly stable is because of the loss of sea ice and the jet stream getting these blocking patterns. And we can also look at the jet stream. This is June 1st, and we can cycle through. So what you can see, so Africa's here, right? You've got a low pressure here. Let's just cycle through. This is June 6th, June 10th. And what you can see now is you can see a high pressure here. Okay, this is because of the jet stream here and up here. This is a high pressure here. Okay. So higher pressure here, lower pressure is down there. It's not that much lower, right? The most distinctive feature is the high pressure up in this region. Okay, and then you can see what's happening. Okay, so what you do is you look at these three different parameters: the dust, the pressure, and the jet streams, and you can relate them to the creation of that dust storm. Okay, now this is a paper, The Atmospheric Drivers of the Major Saharan Dust Storm in June 2020. So I'm going to look at the figures. Okay, this paper is open source, so have a look at it. Again, it's Diana Francis, not Jennifer Francis, and a bunch of other authors, and they looked at the major dust storm in June 2020 over the Sahara. Dust clouds were associated with the highest on-record aerosol optical depth, about double any of the previous ones. And the wave train and the Sahara, so Sahara high, just off Africa, Sahara low, over the continent, the pressure dipole, so high pressure, low pressure close together, pressure dipole, generated the winds, the African easterly jet was generated, the dust went up because of thermal convection up to 6 kilometers and was transported along over to North America. So let's have a look at the actual, so you can read all this about mineral dust is the most common aerosol type on Earth, and the biggest source is the Sahara Desert in North Africa. Okay, and you get the long range transport in these dust events, but so there was a dust event in 2014, there were 2 million tons of dust from the Sahara Desert. This one's probably much bigger. The numbers haven't come out yet. And then you can say this, we have the North African dipole, that's the high and the low, creating the winds, and there's an index, the North African dipole index, which was setting record high levels. But let's have a look at you can read all the details of this paper. I'm just going to show you basically the figures, okay? So we'll go down, where did the figures go? They're at the bottom. What is going on? Hey, my computer's messing up. Okay, come on, down. What is going on here? This is going up and I'm clicking down. Come on, where's the figures? Something's messed up with my mouse. Ah, here we go. Okay. It really doesn't want to let me scroll down. Okay, so this is the Sahara Desert. The yellow is the dust. The white is the clouds. 15th of June, 16th of June, 18th of June, if I can scroll down. Okay, it's getting pretty thick. 19th of June. So huge amount of dust over a large area. We saw this in Earth Null School. These are some of the things that were going on at that time. So this is 200 hexapascals, so that's at the level of the jet streams, and I showed you on Earth Null School. So you get these different jet stream configurations, and this is Africa here. So you get this is for June, and it gives you sort of an averaged number, and then you can see the anomalies here at 850 hexapascals, so that's just above the surface. We have some high here, some lower here. This is the next image is the mean sea level pressure, and you can see, June 21st. Okay, so this is June 5th, and you get these different excursions here of anomalies. So this is a function of, this is longitude here. So you can see these different anomalies at the longitudes that are occurring. And this is the wind speeds here. You can see very, very high wind speeds and so on. There's lots of other details of the storm. Anyway, have a look at it. The Godzilla dust storm